Hello, so this is the homework for place value. So homework problem number 1. It's asking us to convert the number 1,234 in the base of 5 to the base of 10. So first we would take the number and we would place it as expanded form in base of 5 so we can convert it. So 4 would be multiplied by 5 to the power of 0. 3 would be multiplied by 5 to the power of 1. I'm going to have to move this over here. I'll do it up here. 2 would be multiplied by 5 to the power of 2. And 1 would be multiplied by 5 to the power of 3. So this is the expanded form in the base of 5. And now what we're going to do is we're actually going to work all of these out so we can convert it over. So the first number, 5 to the power of 3, well, we just put all of our exponents here. And that will help us. Okay, so 5 to the power of 3 is 125 times 1. So this simplifies to 125. 5 to the power of 2, oh, sorry, let me move this table down. There we go. 5 to the power of 2 is 25, and 25 times 2 is 50. 5 to the power of 1 is 5, and 3 times 5 is 15. And 5 to the power of 0 is 1, and 4 times 1 is 4. And so to convert it to the base 10, we would just add all of this together. So we get 125, 50, 15, and 4. Add all of that. 5 and 5 is 10, plus 4 is 14. Carry the 1. This is 5, 6, 7, 8, 9. And we get 194. All right, here is the next problem. Okay, so we're still in homework problem number 1, but this time we have to convert 1.234 from the base of 5 to base 10. And it's going to work similar to the one above, except since now we're working with numbers behind the decimal, those are going to be exponents in the negative form. Okay, so this one would be here 1 times 5 to the power of 0. And then plus 2, times 5 to the power of negative 1. 3 times 5 to the power of negative 2. And 4 times 5 to the power of negative 3. Okay, so then we would have 5 to the power of 0 is 1, and then times 1 is 1. Then we have 5 to the negative power of 1, which is 0.2, and we would multiply that times 2. So 0.2 times 2, that gives us 0.4. Then we have 5 to the power of negative 2, which is 400ths, so 0.04, times 3, and that gives us 0.12. And then we have 5 to the power of negative 3, which is 8 thousandths, so 0.008 times 4, and that gives this says 32,000, so 0.032. And then we're going to do the same thing. We're going to add everything up. So 1 plus 0.4 plus 0.12 plus 0.032, and we get 1.552. So this would be at the base of 10. Okay, this is homework problem 2A. And for this one, we had to find the base 10 fractions. Okay, so we would have this converted to 1 times 5 to the power of negative 1. And we know that this is actually equal to the 0.2, and 0.2 times 1 would be 0.2, and so that would be its decimal form. So decimal form converted to a fraction would be 2 over 10, which would simplify to 1/5. Okay, we're going to do the same thing here. 2 times 5 to the power of negative 1. 5 to the power of negative 1 is 0.2. And then times 2 would actually equal 0.4. And that is 4/10, which would simplify to 2/5. Next one. 3 times 5 to the power of negative 1. 5 to the power of negative 1 is still 0.2 times 3. We now get 0.6. We have 6/10. That gives me 3/5. You can almost see that, going from the base 5 to base 10, there's that denominator of 5, which is pretty cool. 4 times 5 to the power of negative 1. 0.8, which would give me 8/10, which would simplify to 4/5. All right, this is still continuation of problem number 2. Okay, so this one would be 0 times 5 to the power of negative 1, which would be 0, plus 1 times 5 to the power of negative 2. And for this, we would get the 0.04. Okay, and then that's equal to 4/100, and then we can simplify that to 1/25. Same thing here. We're going to have the same. This will equal to 0. 2 times 5 to the power of negative 2. And then here we actually get 0.08, which is equal to 8/100, which would then simplify to 2/25. just 0 times 5 to the power of negative 1 plus 3 times 5 to the power of negative 2. And that would give me 12. Sorry, I'm just going to double check my math. Yes. 0.12, which would be 12/100, which would simplify. If we did by 4, that would give me 25. 25. 3. And then the last one, 0 times 5 to the power of negative 1 plus 4 times 5 to the power negative 2 times 4. We get 0.16, which is 16 over 100. And we divide that by 4. We get 4 over 25. All right, here's problem C now. Okay, so it's going to work the same way. We'll have 1 times 5 to the power of negative 1 plus 2 times 5 to the power of negative 2. All right, so then when we multiply this out, we get 0.2 here plus times 2 and then plus 0.2, so we get 0.36 or 36 over 100, and then I would simplify by 2. 18 over 50. Simplify again by 2, which should give me 9 over 25. Right?
Mommy. Mama.
Hold on. Okay. Sorry about that interruption. All right, so next we have 2 times 5 to the power of negative 1, 3 times 5 to the power of negative 2, and we get 0.2 times 2 is 0.4, and we get 0.04 times 3, 0.12, so it's 0.4, we get 52, so 52 over 100, 52 divided by 2, now we'll do it by 4. We get 13 over 25. Okay, next, 3 times 5 to the power negative 1 plus 4 times 5 to the power negative 2. 6. 16. And we get 0.76, so 76 over 100 divided by 4. And we get 19 over 25. And then finally, 4 times 5 to the power negative 1 plus 3 times 5 to the power negative 2. We get 0.8 plus 0.12, 0.92, so 92 over 100. And we get 23 over 25. Okay, homework problem number 3. Okay, so for this one, we had to find the base 5 representations for these base 10 fractions. And I'm going to admit it was a little bit difficult for me. I had to look at the solutions to kind of help me. And even then, I'm still a little confused. But what I was looking at was we have this 9 over 25, and we actually got it up here, and we got 0.12. However, when I looked at the solutions, it says 0.14, so I think that's kind of where I'm confused. I understood that because we're in a base 9, this number should not be greater than 9. So the breakup would be 5 over 25 plus 4 over 25. Denominator stays the same. We broke down the 9 into the 5 and the 4. And then it was then simplified. 4 over 25 was already a simplest form. And then 5 over 25 was simplified to 1 over 5. And somehow this changed into 0.14, which I'm a little confused because when we worked the other way, 9 over 25 was 0.12. So that goes to say with part B, 23 over 125. I understand that there was some sort of breakdown here. This stayed the same. And let me see, hold on. Okay, so then this was broken up into 20 over 125 and 3 into 125, in which 3 and 125 was already at its simplest form, and then this was able to be reduced by 4, I believe. Let's see. No, by 5. So we got 25 over 4, and this somehow changed into the decimal 0.043. Okay, so this one is problem 4. And it's asking what number would be right before 100. And this one, again, was kind of confusing to me. I thought of, our number system. That's where we stop. So then over here would be and according to the notes, this is the number that we would see before 100. Okay, so in further looking at the notes, I guess this makes sense because after that, I don't know, it just makes some sense. And so when we get to B, you have 344. And if 44 was right before 100, then 344 might be supposed to be right before 400. Okay, this is homework problem number 5, and it says what number is base 5 in base 5 behaves the way 3 does in base 4. So for this one, I had to think about in base 10, 9 is going to be right before. So for base 4, 3 is going to be before. So in base 5, 4 would be before. So 4 would be the one that behaves like 3 in base 4. Okay, so this is homework problem number 6, letter A. It says to count by 2s to 30 in base 5. So I originally thought we would do 2 4, and then obviously we can't do 6, so we would go on to the next one, which I thought would be 12, but according to the notes at the bottom, we would go into 11, and then 13. So I was just a little confused by this. I thought we'd do 12, 14, and then we would skip 16, 18, and go straight into 20, which it does go into, and then 22, 24. Okay, so after further looking at problem B, the explanation for why these two numbers were even, now it makes sense to me because your sum of the digits needs to be even. So this makes sense because 1 plus 1 is 2, 1 and 3 makes 4, 2 and 0 is 2, 2 and 2 is 4, and 2 and 4 is 6. So now it makes sense why when we count to twos in the base of 5, why we have these, what we would call odd numbers in our regular base 10. And so problem C is for us to count by threes. And so I'm going to assume that there's some sort of rule just like here. I'm thinking like of the divisibility rule. Let me see. I would say something like 3. And if I go to the next number. Okay, so I've struggled a lot with this one. And this is what I got. So I'm thinking, well, this is 5, this is 2. If I add these sum, this is 4, this is 3. So 3, 2, 5, 2, 3. I don't really see a pattern here.